Hey guys, we did some complex conjugates problems when we met virtually last week, but I wanted to do a few more just to kind of go over it with you. I felt like I went through that really fast because I had covered so much other content. So I'm just going to work out the three problems that I gave you in the book on page 165, and we're going to look at the different problems. So we've got 5 over 3 plus I. Well, we know that we cannot have, um, that we cannot have a conjugate in the bottom or a complex number in the bottom. We don't want this imaginary number down there. So in order to get rid of this imaginary number, what I'm going to do is multiply by 1, but not just 1, a fancy one. And the fancy one that I'm going to multiply by is the conjugate of the bottom. Now, why did I say I'm multiplying by 1? Because when I have the exact same thing on top and bottom, it is 1. 5 over 5 is 1. 10 over 10 is 1. 12 over 12 is 1. So 3 minus I over 3 minus 1, or 3 minus I is still 1. So now we can just apply our properties. We're going to distribute. 5 times 3 is 15 minus 5i. Now I could sit here and FOIL this all out. When I have a binomial times a binomial, we know we have to FOIL. Or I could just say, okay, I know the middle terms are going to cancel out, so I don't care about them. 3 times 3 is 9. I times negative I is negative I squared. Or if you want to, you can go ahead and show it if you just want to make sure that you did it right. And then I get minus 3i plus 3i minus I squared. We see that this is 0. I squared we know is negative 1. So 9 minus negative 1 is the same as 9 plus 1, which is 10. So on the bottom, I have 10, and on the top, I have 15 minus 5i. Now, again, because I am me, I am who I am, can't change it, sorry. Wouldn't if I could. Well, actually, that's not true. There's a lot of things I would change if I could. But because I am me, I don't like to write it like this. I like to simplify it as much as possible. So I separate it as the real part minus the imaginary part. And then it's really easy for me to see that I can simplify this. Both the top and the bottom are divisible by 5. So 15 divided by 5 is 3. 10 divided by 5 is 2. And 5 over 10, I know, simplifies to 1/2 I. And that should not be a minus or an equals. That should be a minus. So this is my simplified answer. 3 over 2 minus 1/2 I. So this is number 35 in your assignment. That is how you get that answer. So looking at number 36, it's a little bit different. 36, it says 7 minus 13i divided by 2i. So again, we can't have an imaginary number in the bottom, but thankfully it's not as complex as this number 35 was. There's not two terms, there's just the one term. And I know, got to think back to what I know that I squared is equal to negative 1. So if I can somehow get this I to be I squared, then I'm no longer going to have an I in the bottom. I can change that I squared to negative 1, so then I'm just going to have negative 2. So that's what I'm going to do. I know that if I multiply by 1, I over I is 1. I'm not really changing my problem, but I specifically chose this version of 1 because 2i times I makes it 2i squared. I'm going to distribute on top here, and I get 7i minus 13i squared. So again, let's simplify. 7i minus 13i squared is just negative 1 over 2 times negative 1 minus 13 times negative 1. A negative times a negative is a positive. I can't stand to list it backwards. I've got to have my real first over my imaginary. So positive 13 over negative 2 plus 7i over negative 2. I don't like that plus that negative, so I'm going to rewrite it as negative 13 halves minus 7/2 I. And this is my answer. The real minus the imaginary. I've got my complex number because I have the real part and I have the imaginary part. Okay, so number 37 is very much like this. So I'm going to erase some of this and try again. Let's try number 37. I've got 6 minus 5i divided by 3i. So again, I don't need to do the conjugate because I don't have two terms. I've only got the one term in the bottom. So I'm just going to multiply top and bottom by 1. Fancy 1 in the form of I over I is 1. Again, trying to reinforce that. 6i minus 5i squared over 3i squared. So I know on the bottom I have negative 3. On top I have 6i plus 5. I'm going to rewrite it. I can see that this will simplify, but I have negative 5/3 minus 2i because 6 divided by 3 is negative 2. So I rewrote it as negative 5/3. This is the real part minus the imaginary part. Therefore, this is a complex number. All right, and I really want to try one more conjugate just to make sure that you've got it. So let me delete this. I'm just going to make one up. So let's say I have on top I, and on bottom I have 2 minus I. So what's the conjugate of the bottom? Well, the conjugate of the bottom is going to be 2 plus I. I know that I've got to multiply by 1 or I'm not going to have the same thing. So I've got to multiply the top by 2 plus I. Now I can distribute 2i plus I squared over 2 times 2 is 4. Then I'm going to have plus 2i minus 2i, which is gone, minus I squared. So on top, I have 2i minus 1. On bottom, I have 4 minus a negative 1, which is 4 plus 1, which is 5. So again, I like to change the order. Real first, imaginary second. So this is my complex number answer. Negative 1/5 plus 2/5 I. And that is all I have for this lesson. Hope this is making sense. Hope you guys are watching these and you are trying these problems on your own. Have a great day.